So last week we were talking about drawing cool stuff using equations, and we saw here that we had these equations with these ranges, and when we drew them we got a house, yeah? And so the homework was to draw these 4 equations here and to see what you get, right? Because they didn't know what they would get. So we have a whole bunch of equations here, and if we look at it, we could see that we have some horizontal lines and some vertical lines as well, right? So you know, we have this here is a vertical line, and then we have 2 equations here, right? This here is a horizontal line and a vertical line. This here is vertical, horizontal. This here is horizontal, and then we have 2 equations here that we'll actually have to plot points for, right? So the horizontal and vertical lines, you don't have to plot points for them. So let's tackle those first, right? The first line is x is -4. So you know that x equals -4 is a vertical line passing through the point -4, right? And it's between this range 0 to 2. So when y is 0 and 2, so this line will go from 0 to 2, so this line will go here. Yeah? So you can see here that we have a vertical line passing through x is equal to 4, but we only want it between 0 and 2, right? Next is x is equal to -2 in the same range. So we have this vertical line by -2, and it has the same range, yeah? And now we have these 2 equations here. Well, let's just find 2 points, right? So let's try the first one. The first one, let's try, well, actually, let's go with the ranges, yeah? So we'll use the range. So when x is -4, right? So y is equal to -x minus 2. So I'll put x is -4, 4 minus 2, so therefore y will be 2. So I have the first point, -4, 2. Right? You notice I chose x to be -4, but then this negative outside made it a positive. But I still, because I chose x to be -4, so that's the point, yeah? That's the point, man. And let's choose -3, right? So y is equal to minus x, which is -3 minus 2, which is 3 minus 2, which is 1. So I have -3, 1. So -4, 2, -3, 1. So -4, 2 is over here, -4 on the x, and 2 on the y, right? And then what was -3, 1? So -3 here, and 1 on the y is up to here. So this is the line. It's a very small line because of how small the range is. Now remember, if you just plot the line actually goes all the way through, right? The line is infinite, but the range tells us that we only want it in that area, right? Next one, and please, Caitlin, Soraya, anybody, you know, you all just stop me if it is that you all just don't understand anything or you want me to do over anything, right? I'm just gonna breeze through this exercise because we did a lot of this last week, right? So the next one is y is equal to x plus 4, and let's use the ranges again. So when x is -3, x is -3 plus 4, y is 1. So the first point is -3, 1. -3 plus 4 is 1. Y is equal to -2. -2 plus 4 is 2. So the second point is -2, 2. Is that it? Did I do that correctly? Yeah. So we have negative 3, 1. Negative 3, 1. That's the first point here. And a negative 2, 2. That's this point here. So this line goes like this. Now I'd like you to notice something. The green line is slanted this way. So that's a negative gradient. And you can see here that it have this negative here in front of the x, whilst the other line has a positive in front of the x, and so it's slanted that way. And yes, there is the letter M. Scotia, what was your issues with plotting these things? Why didn't you get this? Right, with the rain, but you understand what I did there now?
Yeah, I'm looking at what I had. I think I have to see in the 8, so I'm just so confused after I did it. I didn't even see it.
But you didn't get the
I
8.
messed up.
Huh? You didn't get the
I
8.
messed up the 8.
Alright, let's try this one here, since this one is only horizontal and vertical lines, right? So we'll do all of the horizontal, vertical stuff quick. So we have the line y is equal to 1. That's a vertical, that's a horizontal line. So at the level of y is equal to 1 here. So that line goes straight across that 1. That y is equal to 1. But it only lasts for this range between x is 2 and x is 4. So therefore, this is the line that we're talking about here. Right? Remember, the line y is equal to 1 goes for infinity. So it's this entire long line here. But I only want it between x is 2 and x is 4. So now I have this shorter line here, right? X is equal to 4 between 0 and 2 on the y. So x is 4, 0 to 2 gives me that. As a vertical line, the line x is equal to 4. And then we have obviously the line x is equal to 2, which is also a vertical line in the same range, 0 to 2. Yeah. So we see here there's a h. Wow, this is looking very cramped up. Yeah. So I wonder where those other things will fall, right? Let's do this one, because this one is also just horizontal and vertical lines. I see here y is equal to 2, and I'll use green for this. Y is equal to 2 between 0 and 2. So y is equal to 2 is over here. That's this horizontal line. The line y is equal to 2. Long horizontal line. But between 0 and 2, that means I only want it from here to here. And then, of course, I want the line x is equal to 1 between 0 and 2. So that's x is equal to 1 is a vertical line. But between 0 and 2 on the y-axis there. Oh, we see we have the t. And now let's see what's going on. I guess this will have to be the a. Right? So let's just plot the easy one first. Y is equal 1.5 and negative 1.5 and a half. That's crazy. So y is equal to 1. Well, that is the same line as this horizontal line there on the h, right? The same line, this horizontal line on the h, that is the line y is equal to 1. So I guess we're doing that, but now we want it between 1.5 and negative, well, negative 1.5 and negative a half. I had to zoom in for that there. Right? So this here is negative a half, about so. And this here is negative 1.5, about so. So this is the horizontal line that I want. Alright? Now let's see these guys here, and we'll just use the ranges as the points, right? So when x is negative 2, y is equal to 2x plus 4. So when x is negative 2 plus 4, that is negative 4 plus 4, which is 0. So when x is negative 2, y is 0, right? And let's plot, well, let's find the other point when x is negative 1. Y is equal to 2 by negative 1 plus 4. So that is negative 2 plus 4, which is positive 2. So therefore, when x is negative 1, y is positive 2. Yeah, that seems it. So let's plot these points here. I'll use the blue for this. Negative 2 on the x is here, and then 0 on the y. Well, that is, 1, 2, 3, so this is 0 on the y. So this point is actually here. Let me do it with the red so you can see it. That's this point here, negative 2, 0. And then I have negative 1 on the x, and then 2 on the y, that's here. Right? And since those 2 points came from our range, all I can need to do is to join them like that. I don't need to draw the whole line. So this here, remember this long line, the line going straight through would have been the line y is equal to 2x minus 4, but we only want it in this range over here, right? Let's do the other line now. So what did you do wrong for the A? Did you recognize? Scosh? Anybody just call this Scosh?
Yeah, my grandma.
Aww. Yeah, so what did you do wrong with the A? Because I noticed the ones that you got wrong are the ones that you had to actually find points for. Yeah?
Yeah, it was the range.
Yeah, the range that messed you up, right?
Yeah.
Alright, so let me do this one a little slower then so that we can talk about that range. So I have y is equal to negative 2x. That's an easy one. Right? And let's use the range. So when x is negative 1, y is equal to negative 2 times negative 1, which is 2. So the first point, x is negative 1, y is 2. Right? The second point is when x is 0. So y is equal to negative 2 times 0. Right? So we can see here that y will also be 0. So therefore this point is when x is 0, y is also 0. So I have those 2 points there. 0, 0 is this one. And then negative 1, 2 is actually the same as this one. That is the point we got up here. Yeah. So now I could just join those there. Now if you look at the range, you could see that what we did was we draw the line y is equal to negative 2x. But look at the range. We only want that line to exist between x is 0 and 1. So if we look here, this here is x, the line x is 0. Remember, that is the y-axis. And then this here is the line x is 1. That is the x-axis. And we can see here that this slant line only exists inside of that range there. So, Scoach, how do you feel about it now? You okay?
Yeah, I'm good.
Now, at the end of the day, what we were doing is we were taking these equations, we were getting equations like this, and we were getting equations like this, and we were finding 2 points. And we could choose any 2 points, we could choose any value of x and find a value of y. So when we find 2 points, then we were able to draw the graph, right? And look, we have some of the examples we did in the last class over here, right? A way to notice something about it, right? Remember, I was pointing out in the last class that when this number in front of x is positive, then the line is sloped like this, right? But when this number in front of x is negative, then the line is sloped like this. So that number in front of x is super important. Yeah? And we also saw that the number after x is also important because it tells us where the line cuts the y-axis at negative 2. Right? We can see here that what is the line? This line cuts the y-axis at positive 3. We can see it here. Yeah? So a way to notice that all of the equations are in a certain form, and that form is the form y is equal to mx plus c. Yeah. Now this here is called the general equation of a line, right? And let's get that going now, right? You can see it right here. So this is the general equation of a line. Oops. And we can see here that we had many different, examples, right? Like the line y is equal to x plus 1. Well, that tells us it has a gradient, right? How steep the line is. So that gradient is a gradient of 1. So that's about so. But then it will be cutting the y-axis at positive 1. So that means that this line will look like that. Right? And we can see that if I had 2x plus 1, the gradient would have gotten even steeper. Right? It would have still be cutting at 1, but it would have gotten steeper. And what if I had y is equal to 3x plus 1? Well, the gradient would have gotten steeper and steeper and steeper. Yeah? So we can see here that this is the general equation of a line, and this number in front, m, is the gradient, or how steep the line is. And you can tell that when this number is a negative, then the line is actually sloped this way instead. Yeah? And this here is the intercept on the y-axis, where the line actually cuts that y-axis right over here. Now this is something that you really need to know, right? Because all the time we were giving you equations and telling you to draw the line. But now what's going to happen is we are going to give you the line, and we're going to ask you to find what is the equation. Okay? So in order to do this, this is the first thing that we need to know. Soraya, Soraya. Sure, Soraya, you ever came across this before? Or even Caitlin?
No.
No. Okay. What about you, Caitlin?
I remember something like this.
Yes, so this here is the general equation of every straight line. Now you see here how I gave you, and sometimes they just want to mess you up, eh? Like for example, the line y is equal to 2x plus 3. You could tell that the gradient here is 2, and it cutting the y-axis at 3, right? So you could tell that this line is going to be sloped in a positive direction, and it's going to be cutting the y-axis all the way up here at 3. Yeah? Or if I gave you y is equal to negative x minus 4, yeah? You could just easily tell, well, okay, that there is a negative gradient. The gradient of this line is negative 1. Yeah? So that means that that line is, the gradient is negative 1, so it'll be sloped this way, but they're going to cut the y-axis at negative 4 all the way down here. So that line might probably look something like this. Yeah? So just by looking at the equation of a line, you are supposed to be able to tell what the line looks like. But sometimes they wouldn't give it to you like this. Sometimes they might want to give it to you like this. Y minus 2x is equal to 3. And you would have to know, they're going to tell you plot this. And you will have to know, hey, I need to take this and throw it over in order to get y is equal to 2x plus 3, so that it would be in this form. Yeah? You can't just watch the number in front of x. Because if you just look at the number in front of x, you would think that this line has a negative gradient. Right? But no, it is not in this form. So you have to take the equation and put it in this form, mx plus c. Right? Now let's take a look at an example here, right? Well, we have a couple of examples, and this is just what I was talking about here. So the general equation of a straight line is mx plus c. And we could see here m in this case is 2 and c in this case is 5. And we could see here that it actually cutting the y-axis at 5. Right? In this case, m is negative 3, so that means it's sloped in a negative direction. But it cutting the y-axis at positive 2, we could see that. Right? Let's look at the horizontal line. The horizontal line has 0 gradient. So when m is 0, well then that get rid of x there, and that is how we end up with the horizontal line just being y is equal to whatever c is. Right? And with a vertical line, and this one is a little hard to imagine, right? But just know that when you have a vertical line, the gradient of a vertical line is actually infinity. Yeah? So I want you guys to actually make a note of these 4 different types of gradients and tell me when you're done. Yeah? You have the positive gradient, so m here is positive. You have m here being negative. You have m here being 0, so it's flat. And then you have m here being infinity, so it's actually vertical. And only a perfectly vertical line would be infinity. So we could tell here, this is just a little example. We have positive gradient, negative gradient, negative gradient, positive gradient, right? So I hope that everyone is okay with recognizing when a gradient is positive, it's slanted this way, right? Slanted upwards to the right. And then when a negative gradient is slanted upwards to the left, right? So so nice. Now, what's gonna happen is this. You're going to be given a line, a random line, and you're gonna be told to find the equation of the line, right? The first thing you're gonna have to do is you're gonna have to look on your graph and find 2 points and write down the coordinates of those points, right? So let's just say that this is the first point. We'll say that this is x1 and this coordinate here is y1. So we'll call this point x1, y1, right? And let's just say this point here will be x2, y2. So a way to get used to seeing points looking like that. Now some questions will not give you a graph. Some questions will just give you the 2 points. So they don't even have to actually give you the graph and show you the graph. They'll just tell you the 2 points and they'll just say, hey, find the equation of the line that joining them 2 points. And so this is the example that we have here, right? We have find the equation of the line. Well, we'll get to that. And remember, the equation of a line is y is equal to mx plus c, right? And the equation of the line joining these 2 points here, so 1, 3, and 5, 7, right? So we have the point A being 1, 3, and the point B being 5, 7, right? If you want, you could draw it, but they didn't really ask you to draw it, right? So we want to find the equation of the line, and we can actually write this down. Find the equation of the line joining A to B. Yeah? And remember, this is all we know, that y is equal to mx plus c is the general equation of every line, right? So the first thing that we have to do is we had to find m and we had to find c, right? Finding m has a very special formula, and I'm sure that some of you may have met the formula before. But to find the gradient of a line M, we just have to know this formula, y2 minus y1 divided by x2 minus x1. So Shazay and Scotia, I'm sure you guys are familiar with this formula, right?
Okay.
Shazay, you okay with this? Yeah, right? And the Form 4s might be meeting it for the first time, but this is a Form 4 topic, so you guys do need to know this, right? Now, obviously, we could see here that we're dealing with 2 points. It have 2 y values and it have 2 x values. So in order to find the gradient, we need 2 points, right? So we could let anything be x1 and anything be y1. So let's just say if this is x1, well then this will be y1. If this is x2, this will be y2. Now if you had chosen this point to be x2, y2, and if you had chosen this point to be x1, y1, you would have get the same answer. So you don't have to study it too much, right? So we say, well, all right, let's just choose this to be x1, y1, and let's just choose this to be x2, y2. So therefore the gradient M is equal to y2, whatever we chose to be y2, which is in this case 7. Yeah, so y2 is 7 minus y1, which is 3, divided by x2, which is 5, minus x1, which is 1. Yeah? And now we'll have the gradient 7 minus 3 is 4, 5 minus 1 is also 4, and the gradient is 1. So we could tell now that M is going to be 1, right? So now we have the line y is equal to 1x plus c, right? We almost have the equation of the line, but we just need to find c. C is where, C is where the line cuts the y-axis, right? So any ideas as to how to find C? Scotia and Shazay, you guys should know this. Now at the end of the day, let's just do a recap. We were asked to find the equation of the line joining A to B. So we see we have 2 points A to B. We want to find the equation of the line joining those 2 points. So all we have to do is use this formula. Once we have 2 points, this formula becomes easy. y2 minus y1 over x2 minus x1. So we were able to find the gradient, which is M, right? So we could see here that we have M, but we need to find C. How do you think we could do that? Well, look at this. We have 2 different examples of x and y, and the point A is supposed to lie on this line, right? So therefore the point A tells us that when x is 1, y is going to be 3. Yeah. The point B tells us that when x is 5, y is going to be 7. So we can use any one of the points. We don't need to use 2. We can use 1. So let's just use point A, because point A is easier, right? So from point A, which is the point 1, 3, implies that, well, y is equal to 3, so I'll just put 3 equals to M, which is 1, multiplied by x, which is also 1, right, plus c, right? So this means that 3 is equal to 1 plus c, so therefore c is equal to 3 minus 1, c is equal to 2. So now, therefore, the equation of the line joining A to B is y is equal to M, which is 1, x plus c, which is 2. And of course, we don't need to write 1x, So we could just write y is equal to x plus 2, and that is it. So if we recap here, you can see that generally when you are being asked to find the equation of a line, they will somehow give you 2 points to work with. From them 2 points, you could find the gradient using this formula. That gradient is m. And you could use one of the points to find what c is going to be. And boom, you have the equation. So Shazay and Scotia, how you guys feel about this? Is it easy or is it hard? Here what? I want Olit to do these two here. Right? So what you all have to do is find the equation, or I'll put equations of each line. First one is the line AB, and you're given the points A and the points B. And the second one is the line CD. You're given the point C and the point D. So this is 2 different lines, by the way. 2 different lines, so they don't have nothing to do with each other. These are 2 different questions, right? So you have 2 different questions, and I have a reason why I'm giving you these 2 questions here. 2 different questions. How much time do you all think you need for it?
8 minutes.
I like a very mathematical answer there. Alright, take 8 minutes. Find the equation of each one of them lines. Now AB, let's go with AB. So AB, come on. So the line AB, the line joining A, which is 5, 6, to B, which is 1, 4. Alright, let's check this out. So first I know that equation of a line is y is equal to mx plus c. Notice the statements that I write it, right? Notice that I'm gonna always put this first, right? M is y2 minus y1 all over x2 minus x1. So let's find m, right? Let's call this x1 y1, and let's call this x2 y2. Remember, you could switch it around if you want, it really doesn't matter, right? So y2, which is 4, minus y1, which is 6, all over x2, which is 1, minus x1, which is 5. So we can see here that 4 minus 6 is negative 2, and 1 minus 5 is negative 4. Am I correct? Yeah. Of course, the negatives will cancel, and I'll just end up with a half. So m is a half. Well, Scotia, looks like you might be onto something. Yeah. So m is definitely a half. Now let's find c, right? So therefore, y is equal to a half x plus c. Let's use the point b because it has smaller numbers, so it should be easier, right? So therefore, b being the point 1, 4 implies that y, which is 4, is equal to a half x, which is 1, plus c. Yeah? So 4 is equal to a half plus c. So c is 4 minus a half, which is 3 and a half. Right? Which is 3 2s are 6 and 1 is 7 on 2 if you want to go that route. So therefore, the line AB implies y is equal to m, which we got to be a half, x plus c, which is 7 on 2. I don't think you got c, right, Scotia?
I hope not.
How you get 8.5? You sure you didn't write 3 and just tell me 8?
No, I had 8.
How did you get that 8? Did you use the A point?
I did.
You did? Well, you should have gotten the same thing. Right? You want to use the point A and C? Let's use the point A and C, right? Using the point A, which is 5, 6. 5, 6. Is that really the point A? 5, 6? Yeah, 5, 6, 1, 4. Okay, good. Now what is this? Y is equal to a half x plus c. So I think I know what you did wrong. You probably substituted the wrong values, because in this case y is 6, so y is 6 is equal to a half x is 5 plus c, right? So 6 is equal to 5 on 2 plus c. Yeah? So c is equal to 6 minus 5 on 2. 6 is what? 6 is 12 on 2, and so c is equal to 12 on 2, which is 6, minus 5 on 2, which is 7 on 2. So let's find the line joining C, which is negative 3, 6 to D, which is 2, negative 3. I hope I got that right. So again, I will state, right, general equation of a line implies y is equal to mx plus c. So we just had to find m and we had to find c. So m is equal to y2 minus y1 over x2 minus x1. So let's call this our x1, y1. Let's call this one x2, y2. So therefore y2, which is negative 3. Now the reason why most of you would have gotten this wrong is because of these negatives. So please employ the use of brackets as you are about to see. y2 is negative 3. So I'll put y2 as negative 3 in brackets, minus y1, which is 6. Yeah? All over x2, which is 2, minus x1, which is negative 3. You had to be real careful about, because some people would have just put 3 under here because of this minus. Yeah? So be real careful. Always use these kind of brackets when you're making substitutions, right? So I think minus 3 minus 6 is minus 9, all over 2 minus negative 3 is 2 plus 3, which is 5. So negative 9 on 5, where's my calculator? 5, that is negative 1 4/5. That's where you got, Scotia?
Yeah.
Alright, so we can actually leave it as negative 9 on 5. I actually prefer improper rather than mixed numbers. Mixed numbers look too complicated. So therefore y is equal to negative 9 on 5 x plus c. So now it's time to find c, right? So we could use which one did you guys use? Let's use D, because D have smaller numbers. D being 2, negative 3, implies y is negative 3. So I'll put negative 3 in place of y. And that is equal to negative 9 on 5 x, which is 2, plus c. Right? So negative 3 is equal to 9 2s are 18. Negative 18 on 5 plus c. So therefore c is negative 3 plus negative 18 on 5. Don't know where my calculator is, but I do have a trusty calculator lady. So the calculator lady could help me out here. What did you, wait, actually, no, this is wrong. It's plus 18 on 5. Because if I throw this across, it'll become plus 18 on 5. So negative 3 plus 18 on 5, calculator lady, help me out.
3 over 5.
3 over 5, for real?
Yes, 3 over 5.
Alright, no.
That's
Yeah, but the thing is, right, and just make a note, with these kind of things, and generally with maths in general, unless they tell you 2 decimal places, you shouldn't use decimals in maths. You should try to use fractions. Fractions are more exact. Now, especially in the equation of a line, you want to stay away from decimals. You want to use fractions. So therefore, this line CD equals y is equal to negative 9 on 5x plus 3 on 5. Is that what you got, Scotia? So this is just a general summary, right? When it is that you want to find the general equation of a straight line, you are normally given 2 points. So when you are given 2 points, the first thing you do is find your gradient m, right? And then once you find the gradient m, you could use that with this equation and a point. So take any one of these points here and substitute it into the equation with m, and you should be able to find c. And then the most important thing is state the final equation that you find it, right? So Shazay, you okay with this?
Yeah.
Caitlin, you okay with this?
Yeah.
Right? So when you're finding the equation of a line, there's 2 things you had to find. M and you had to find C. Yeah? And I think we know how to do that. Right? So it only have a couple of other things that we have to do in this class. I am about to show you guys a couple of formulas. Those formulas are going to look very, very hard, but they're not. They're actually quite easy, right? So let's just take a look at these formulas. It's just a couple formulas again, and then we'll be finished, right? So the first thing I want to talk about is the gradient of parallel lines. And just make a note of this, yeah? You see we have the line, the pink line, y is equal to negative 2x. And you could tell the negative gradient. And then you could, well, first of all, this here is of the form y is equal to mx plus c, where m is negative 2 and c is 0. And we can see here that the line cuts the y-axis at 0. So you could just look at this line and tell what it will look like. Right? We could see here that m is negative 2 for this line. But for the red line is a different line. It's cutting the y-axis at positive 4. But it has the same gradient, negative 2. Right? So you can see that when 2 lines have the same gradient, they are parallel. Parallel lines have the same gradient. So just make a quick note of this and tell me done it when you're done. Now this next one, so this is one point that when you have 2 lines and they have the same gradient, which is the number before x, then they are parallel. Now you see these 2 points here, this parallel line thing, they like to bring it in CSEC. They love to bring it in CSEC. So you had to start to notice these things, right? And this next slide here is one that they also love to bring in CSEC. So how can you tell if two lines are parallel? The gradients are the same. But this next one is how can you tell if two lines are perpendicular? Perpendicular means 90 degrees, right? So how can you tell if two lines are perpendicular? Please pay attention to this one because they love to bring this in CSEC, yeah? And how can you tell if two lines are perpendicular? Well, you have to look at their gradients, right? And this is it here. When you take the gradient of the two lines and multiply them, you will get -1. So if you take the gradients of the two lines and you multiply these gradients and you get -1, that means that those two lines are perpendicular. So we have y is equal to -2x, y is equal to 1/2x. Hey, are these two lines perpendicular? Well, let's check. I'll take the gradient of the first line, which is -2, and I'll multiply it by the gradient of the second line, which is 1/2. And what will I get? Well, 2 is crossed into 2 to give me -1. -1 times -1 is -1. Look, I get -1. So that means that they are perpendicular, right? So again, they love to bring this. This is a nice little thing that you know is a little 3 marks in the corner that they just bring, and the real people just get it wrong because they just can't remember this little thing right here. So write it down and let me know when you're done. So we have an actual CSEC question here. You can see here that they didn't give you 2 points. Yeah, they didn't give you 2 points. What they actually did, and they just hardly do this, but I find this one. What they actually did was they actually give you a graph. They actually give you a graph, right? So what you need to do is use the graph and find 2 points that are on the line. Find the 2 clearest, easiest points that you could find. Yeah, you might want to use a point like this because, you know, well, maybe you might have to average 1/2 for this, you know, or a point like this where you might have to average 3/4. No, so don't use them kind of points, right? So with a question like this, you actually have to use the graph and find 2 points on the graph, right? When you get your 2 points, use the graph to determine the gradient of the line. And once you find the gradient of the line, well, then you can find the equation of the line, right? And then once you find the equation of the line, I want you to find the equation of the perpendicular line that passes through the point P. I'll give you all a little hint there, and all you know that you just had to plug in a point to find C, which is the intercept on the y-axis, right? But I mean, maybe you don't have to do that because you have a graph, so you can literally see where the thing cut in the y-axis. So maybe you don't have to do no algebra to find C. Now, using the graph determine the gradient. Well, I know in order to do any of this, I need 2 points. So let me look at the graph, and I'm seeing that none of these points looking very pointy. I mean, yeah, I could estimate what they is. This is 2.5 on the x, but not 5 for that. All right. Look, I have 2 very clear points I see in here. This is one, the point P itself, and this is the other one. So what is this point over here? Well, the x value is what? Well, you know, x is 4 here, x is 3, x is 2, x is 1. So over here, x is 0, right? And we see in y, the y point is what? 1, 2, 3, 4. 0, 4. So I have the point 0, 4 is 1 point. And now let's look at the point P. So the point P, where's the x value? 1, 2, 3, 4, 5. And where's the y value? We can see that its y is 0. This is y is 1, y is 2, y is 3, 2, 1, and then y is 0. So the point P, y is 0. So you could see here that once you have points that are on the axes, then one of your coordinates is going to be 0, right? Depending on which axis you're on. So I have the 2 points there. Let's call this point Q, right? PQ, right? So now the gradient of the line M is y2 minus y1 over x2 minus x1. So that is, let's use this as x2, y2, and let's use this as x1, y1, right? So y2 is 0 minus y1, which is 4, all over x2, which is 5, minus x1, which is 0. So we could see here that we have negative 4 divided by 5. So therefore M is negative 4 over 5. And it makes sense because the line has a negative slope. So you would expect that that M would have been negative. So did you guys get through with the gradient?
Yes.
Alright.
Yes.
Nice, so at least we have that one. Now we want the equation of the line. The equation of the line y is equal to mx plus c, where c is where it cuts the y-axis. Now I could use any point to find c, yeah? Because look, we have y is equal to negative 4 over 5x plus c. Let me just say I use this point to find c. X is 0. So if I put x to be 0 here, yeah, and remember y is 4, so and y is 4 and x is 0 here. Well, this entire thing gonna cancel out because it is 0, and we're gonna just end up with c is equal to 4. Yeah. So we could have used the point, but we didn't have to use the point because we could actually see that this line is cutting the y-axis at 4. And so c will be 4. Y is equal to negative 4 over 5x plus 4. So did you guys get through with the equation?
Yes, sir.
Right. So now what we want is we want this number 3, right? The number 3 just now is the equation of the perpendicular line. So the perpendicular line go look so, and because it's 90 degrees, right? That passing through this point P here, which is 5, 0, right? So what do we have? We have the equation of the first line. Y is equal to negative 4 over 5x plus 4. We have the point P, which is 5, 0. That's all we have, right? Remember, when we draw this perpendicular line, right? This point over here no longer could help us. This point not on the perpendicular line. So this point cannot help us. But this point P is on the perpendicular line. So that point P can help us, right? So what do we know about perpendicular lines when it comes to coordinate geometry? What do we know?
Wait, no, sorry, class, but the two things that
The two gradients. When you multiply their gradients, you'll get -1, and
yes, that's what I was supposed to
that
say.
is what you're trying to say, yes. And that is the only thing we know about perpendicular lines when it comes to coordinate geometry, is that when you multiply their gradients, you get -1. So I want to find y is equal to mx plus c. So when I take this gradient and this gradient and I multiply them, I'm supposed to get -1, right? So when I take this gradient m, let's call it mp for the perpendicular that's passing through p. Yeah, so we'll call it mp. So when I take the gradient mp and I multiply it by this gradient, -4/5, if they are perpendicular, I am supposed to get -1. And so therefore mp is equal to -1 divided by -4/5. mp is equal to +5/4. Right? And it makes sense that this is a positive, because you know the perpendicular line would go in the other direction. You can see it have a positive gradient. Yeah. So Scotia, you're okay now with this? You understand what I just did there? So the whole point is that we only know this one thing, that if you have two lines and you multiply their gradients, if you get -1, when you multiply the gradients, you get -1, that means they are perpendicular. If you don't get -1, then they're not perpendicular. You understand that?
Yes, sir.
Right? So that means that when it comes to these perpendicular lines, if I take the gradient of this line and I multiply it by the gradient of this line, I am supposed to get -1, and
Yeah.
yeah. So what I did was, if I take, this is the general equation of the perpendicular line that I want to find. Yeah, I don't know what it is, right? But I want to find the gradient of it, right? So if I take the gradient of this line that we just found, and and I multiply it by the gradient of this perpendicular line, which I don't know, that is supposed to give me -1 if they are perpendicular. You understand that?
Okay.
You sure?
Yeah.
So now it's just a matter of flinging that across to get +5/4. You okay now?
Yeah.
And if you want confirmation, you take 5/4 and you multiply it back by this -4/5, and guess what? You will get -1. Right? So this here is the gradient of our perpendicular line. Y is equal to 5/4x plus c. How could we find c? Because we certainly can't see here on the graph where it cut in the y-axis. We can't see that. It's cut in the y-axis somewhere way down there. Alright? So how could we find c? What is the one other way we know to find c? And we use a point that was already on the line. And didn't we use a point that we were sure was on the line? And is there any point that we know for sure is on this line?
P.
Yeah. So the point P says x is 5, y is 0. So y is 0, x is 5 plus c. Alright? 5 5s are 25. So that's 25 on 4 plus c is 0. C is equal to -25 on 4, which is what? That is 5 fours are 20, 6 fours are 24, so that's negative 6 1/4, right? Yeah. So C is negative 6 1/4, and we could see here that this line we could imagine that that would definitely cut somewhere down by negative 6 somewhere over here. So now I have the equation, therefore equation of perpendicular, because I don't like to write the word perpendicular, so I just always use this symbol here, is y is equal to 5 on 4x minus 6 1/4. So just to recap, right? In order to find the equation of the perpendicular line that's passing through P, you can see I draw it here. The first thing I recalled was that when you multiply the two gradients, that is the only thing I know, is that when you multiply the two gradients, you are supposed to get negative 1. So that is what I did here. I multiplied the two gradients to get negative 1, and therefore I was able to find the gradient of the perpendicular line. So I found the gradient of the perpendicular line, and it's just to use the point P to find what C is. Caitlin, how are you feeling about this?
Okay.
Okay, you have any questions? Before we move on, real quick, because I asked you all to do this before the break and nobody did it, right? So let's talk about a cheat sheet for coordinate geometry.
I did my cheat sheet.
Oh, you did? You uploaded it?
Yeah.
All right, I'll check it out. I didn't check it out yet, so I will, right? So coordinate geometry, we know the first thing we know is we need 2 points to draw a line, right? Y is equal to y is equal to mx plus c. That is one thing that we just learned there. The next thing is where m is y2 minus y1 over x2 minus x1. The next one is where c, you could use a point to find c. And just remember that it is the y-intercept. Right? And am I missing anything? Oh yeah, of course. Perpendicular lines. When you multiply the gradients of perpendicular lines, you get negative 1. And for parallel lines, the gradients are equal. Right? So we have this little cheat sheet going on, and this is kind of what we learned in the class today, a lot of it, right? We have 2 more formulas to learn before I let you go. Right? As I say, the formulas will look hard, but they're not hard at all. Right? Now this here is a question that I want you to do for the next class. You'll notice it's the same kind of question as the one before. You use the graph to determine equation of the line, the gradient of the line, the equation of the line, and the equation of the perpendicular passing through the point P, which is this point here. Even though it's not marked off as P, I'm sure that you could guess that that is point P. Right? So the perpendicular line. So I expect this for Saturday's class, right? So that you guys, or unless all you want to do it now, right? But I have 2 formulas for you here, and the first one looks like this. Oh my God. So write down this formula for me real quick, and let me tell me when you're done it, and then I'll explain. So obviously you have a line, and the line is between 2 points A and B, and you want to know what is the length of the line AB. Well, to find the length of the line, we just use this formula. You can see the formula you just find x2 minus x1 and you have the y2 minus y1. So you minus the y's from each other, you minus the x's from each other. Now, I was asking the question, Shazay, Scotia especially, maybe even Caitlin and Soraya, maybe. But does this look familiar to you all? Does this remind you of anything?
Yeah.
Yeah. So what this actually is, this came from Pythagoras Theorem, right? And you don't have to know the proof of where it comes from for CSEC, but it's always good to know it, right? Because if you want to find the length of a line like this, we could first form a right angle triangle like that. And let me just say this is the x-axis and this is the y-axis, right? So when we form the right angle triangle, we have the point C here, right? And we can see that the hypotenuse is AB, this here is AC, and this here is BC. And what do we know? We know that AB squared is equal to AC squared plus BC squared, right? So this is Pythagoras Theorem, and therefore AB will be the square root of AC squared plus BC squared. Does it look familiar to you now?
Yeah.
Something so, right? So it's just a matter of actually knowing the formula, right? And if you guys are interested in how the formula came about, because as you can see, if you want to find the length of a line, you just have to plug the values in the formula and you're good to go. But this next slide kind of tells us how the formula came about, right? You see that we formed the triangle here between A and B. And we need to know where's the length of this line. Where's the length of this line? Well, you have this x2 value over here for B, and then over here you have the x1 value. So the length of this line will actually be the x2 value minus the x1 value. So you're minusing this and you'll be left with the length of that. You could tell here that the same kind of thing goes for the other side. How can you find the length of this side? Well, you take the y2 value over here, and if you minus that, so this entire thing is y2, and then from this point here you have y1, so this is y1, and if you minus y1 from y2, you'll just be left with this length over here, right? So it might look a little confusing, but it's actually how do you feel, Scotia? Are you confused by this, or does it make sense?
Okay.
Alright, and as I say, CSEC will never ask you to prove it, but this is kind of how it's proven. So you can see here that they employed Pythagoras Theorem. AC, which is this, is x2 minus x1, and then BC, which is this, is y2 minus y1, and then they throw the square across to give you a square root, and so we have the final formula here. So even though the formula looks like this big long hard thing, it's really just an application of Pythagoras Theorem, right? So let's talk about, let's just do one example and see, right? So where's the formula? AB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Right? So we want to find the length of these lines here, right? So let's just call this, and again, it doesn't matter which one you choose as x2 and x1. So let's say this is x2, y2, and this is x1, y1. So the length of the line is the square root of x2 which is 4, minus x1, which is 1, all squared, plus y2, which is 5, minus y1, which is 1, all squared. So therefore, what do we have here? We have the square root of 4 minus 1 is 3 squared, plus 5 minus 1 is 4 squared. So AB is equal to the square root of 9 plus 16, which is square root of 25. No, 9 plus 16 is not 25. Wait, 2 3s are 9, 4 4s are 16. What's 9 plus 16? Yeah, it's 25. Yeah, it is. So it's 25, which is 5. How will I find it is? Hard or easy? Yeah, it's just a matter of knowing your formula. So here what? Give this a write down, and then once you write this down, try this one. So I'll give you 2 minutes to write this down, and I'll give you 2 minutes to do this one. That's 4 minutes. So you have 4 minutes, and then we'll have the last thing that we have to do. We just have one more thing to do after this. Now let's take a look at the length of this line. Let's also call it AB for the sake of argument, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So that is, let's call this the 2's and let's call this the 1's. Yeah? So that's the square root of x2, which is minus 9. So I'm going to put negative 9 in brackets, minus x1, which is 7. I'll put 7 in brackets. And I'm going to put all of that squared. Okay? Plus, you notice I'm using my brackets. y2, which is 4, minus y1, which is negative 8. And all of that squared. Right? Notice the use of the brackets, right? So the square root of negative 9 minus 7, 18, 17, 16. So that is negative 16, is it? Squared, right? Plus, and please tell me if I'm going wrong, negative 9 minus 7 is negative 16, I believe, right? And 4 minus negative 8 is 4 plus 8, which is 12 squared, right? So you know if you square a negative, you just get a positive. So what is 16 squared? Somebody help me out here. I don't have my calculator. $16 squared is what? Calculator lady.
256.
256 plus 12 squared is 144?
Yeah.
So where's 256 plus 144?
400.
400 flat?
Yeah.
And what is the square root of 400? 20?
Yep.
Yeah.
But how you
But
messed up
after
this?
that, put on negative 16 squared, I get negative 256.
Oh, but remember, if you have like a negative 5 squared, that is negative 5 multiplied by negative 5, and a negative is a positive, eh?
Yeah.
Yeah? But please be reminded, and we did this, we did this in class. If you have negative 5 cubed, that is negative 5 times negative 5 times negative 5, which is negative times a negative is a positive, so that's positive 25 times negative 5, so you will get negative 125. You understand? So at the end of the day, the whole positive thing does only work when the power is even. So when the power is even, you'll get a positive answer. When the power is odd, you'll get back your normal negative answer. You understand? Right, so we have the length of a line, and we have this real stupid looking formula that we have to learn for the length of a line. The other formula that we have to learn, the last one here now, is the midpoint of a line. So the midpoint of a line, this is the formula. Take a minute and write it down, then I'll explain it. 1 minute please, just say done it when you're done. While you're writing, notice the formula is in the form of a point, a coordinate. You have brackets, you have the x coordinate, comma, the y coordinate, close brackets. Yeah, so that is, just notice that. The midpoint is, the formula for it is itself a coordinate. I mean, this is pretty self-explanatory. You have a line between the 2 points A and B, and A is x1, y1, and B is x2, y2. And you want to find where's the midpoint, the point exactly in the middle. And you know what questions they love to ask you sometimes? They're going to ask you to find the midpoint, and then they're going to ask you to find the equation of the perpendicular line passing through the midpoint. And you just do it just like how we did that P thing, right? So we have the midpoint here, and you know, to find the x value, the midpoint is a coordinate. So to find the x coordinate is x1 plus x2. You add the x's divided by 2. To find the y coordinate, you add the y's divided by 2. And that's pretty much it, right? Why do I have this slide twice? All right, I don't know, right? And of course, we have some questions here. So I'll just do one, and then you will do one, and then that should be it for today, right? So the midpoint equation, I'll just leave it up here so that you can see it. So let's find the midpoint of these two here, right? A, right? So the midpoint M is equal to, I'll add the x's, 2 plus 6 all over 2, comma, I'll add the y's, 4 plus 10 all over 2, right? So M is now equal to 2 plus 6 is 8 over 2, 14 over 2, which is what? The 0.47 is the midpoint of M. Big M, not small m. Sorry for writing small m. Is big M, because remember small m is gradient. Right? So big M is midpoint. Yeah? So we have the 2 points here, right? And we were able to use this very simple formula to find the midpoint. Do H for me. You have 1 minute. Say done it when you're done. And if you want, you can write this one down too, but just do H, really. I'll give you 2 minutes to write this one down if you want to go. This one is for the points, the midpoint of 2, 4 and 6, 10. So write this down and do H. You'll have 2 minutes. Say done it.
I just finished.
Alright, so let me try, right? So we have the point here, 0, 5. And the other point is negative 11, negative 10. And we want to find the midpoint. M is equal to, we add the x's. So the x's is 0 plus negative 11 over 2. And then we add the y's. The y's are 5 plus negative 10 over 2. And so the midpoint here now, did I do that correct? Y is 5, negative 10, x is 0, negative 11. So the midpoint is just simply negative 11 on 2, and 5 minus 10 is negative 5 on 2. Shizay, you got that?
Yes.
Alright, better. Alright. So that's it for today, guys. Now you can see here we had a little cheat sheet going, and we just need to add a couple of things to this cheat sheet, right? And that is the length of a line and the midpoint of a line. Those two formulas here, right? What I want for Saturday is I want you to upload, you know where the cheat sheet assignment is, I'll show you. I want you to upload your cheat sheet for the whole of coordinate geometry, not just this class, but since we started coordinate geometry. The cheat sheet for coordinate geometry. So just write this down. This is what I want for Saturday. I'll show you guys where to upload it, right? So you can see here what we looked at today. We saw that whenever you're dealing with a line, you definitely want 2 points or a point. We saw the general equation. We saw how to find the gradient. We looked at some ways to find the y-intercept. We saw parallel lines have equal gradients. We saw perpendicular lines have gradients that equal to -1 if you multiply it. And we also saw some dumb looking formulas for length and midpoint of a line. So this basically concludes the topic of coordinate geometry. We have finished coordinate geometry there, but for Saturday, I do want you to do, and I will show you where you'll find this PDF. But for Saturday, I want, remember this question, right? With the perpendicular line, well, I want this one. This is the question we did in class. So slide number 13 is the question that you have to do for homework, right? As well as slide number 22 is the question, this question, especially part A. You should be able to do part A and a part of part B, right?